Okay, guys, continuing on with section 9.2, we're going to find out about radian measure today, and hopefully you watched the little intro video or had our radian intro. We're going to skip right down on this worksheet. So this is kind of an intro to radians, and these notes are posted, or I have talked about that information. I'm going to skip right to converting from degrees to radians and vice versa here. So we're just going to jump right in and talk about how to convert from degrees to radians and then back. And I'll do those two examples. So I'm going to do this kind of backwards. I'm talking about converting from degrees to radians. And I'm actually going to start over here, converting from radians to degrees. Normally it's not too bad. So they'll give us an angle in radians. And radians don't have any units, something that's a little bit weird. Usually we have units, but they'll take on whatever the units of the radius are when we use them. So we just have an angle in radians. To convert to degrees, we're going to multiply by 180 degrees divided by pi. And hopefully this kind of makes sense because we decided that half a circle, there were pi radians in it. So that's how we'll do that. To convert from degrees to radians, it's the opposite. So we'll have the angle in degrees. I'm going to put the little degree symbol, and we multiply that by pi divided by 180 degrees. And here we want to think about like your degrees should essentially cancel. We'll have degree in numerator and denominator. Here, usually radians, we've got like pi in it, so normally those pi's would cancel, but that's not always the case, so you can't always kind of rely on that. Okay, so let's go up to these two examples here. So first one, we're given 270 degrees, and we want to convert to radians. So I'm going to write out 270 degrees, and to convert to radians, so degrees to radians, we're multiplying by pi divided by 180 degrees. So we should be able to do this without a calculator. We want to leave our answer as a fraction and not a decimal. So first I'm going to cancel out the zeros, and I get 27 pi over 18. And I know that 9 can go into both of these. So 9 goes into 27 3 times, and 9 goes into 18 2 times. So that would be my answer, and we would say that like 3 pi over 2. All right, second one, convert pi over 3 to radians. I'm going to actually talk about two ways to do this. So the first would be just using this formula we have. So converting radians to degrees, I'm multiplying by 180 degrees divided by pi. And we'll notice here that these pi's are going to cancel, and I'll just get 180 divided by 3, which turns into 60 degrees. So that would be that one. Another really nice, easy way to convert to radians, and this should actually say convert to degrees. That's what we did. It's already in radians. Got to fix that. But to convert to degrees, if we're given something like this, pi divided by 3, in degrees, pi is 180. So anywhere you see pi, when we're converting, we can actually just sub 180 in for it, and that's what we'll get. But these two conversion formulas will always work out. So that's converting from degrees to radians and radians to degrees. I'm going to go over this little circle down here with our common measures for angle measures to degrees. And we actually already did this first one, 60 up there. We found 60 degrees was pi over 3 radians. I'm going to put a couple more in here. Hopefully one that we've seen is 180 degrees is pi radians. And this is really helpful in getting all the others. So I'm going to write like inside the circle. For example, let's go to 90 first. 90 we can get by taking 180 and dividing it by 2. So if we took 180, which is pi, and divide it by 2, we would get 90 up there. All right, maybe I'll do one more with the conversion instead of using that kind of trick. So 30 degrees, to get in radians, I'm going to multiply by pi divided by 180. To simplify, I'm going to cross out these zeros. So I'll get 3 pi over 18, which is really pi over 6. All right. So I'm going to think about the other ones a different way, like 45. I know 45 is really 1/2 of 90. And I already know that 90 is pi over 2 radians. So if I multiply 1/2 times pi over 2, I get pi over 4. So there's like these first quadrant angles, we call them, right? Pi over 6, pi over 4, pi over 3. The rest we can all get by doing multiples of these. So for 120 degrees, that's really 2 times 60, right? 2 times 60. So I'm just going to take pi over 3 and multiply it by 2. So this guy would be 2 pi over 3. 135 I can do as 3 times 45. So that would be 3 times pi over 4. 150 we can do as 5 times 30 degrees. So that would be 5 pi over 6. And we can keep going with that throughout. So I'm not going to talk about every one, but this guy we could do as 3 times 90. And again, these can all be multiples. So this guy could be 7 times 30 degrees, so 7 times pi over 6. I'm going to skip around all those pi over 6's because this is 11 times 30 degrees, so 11 pi over 6. Let's go to 240. That's really 4 times 60, so 4 pi over 3. 300 is 5 times 60, so 5 pi over 3. 225 is 5 times 45. So 5 times pi over 4. And finally, 315 is 7 times 45. And I've seen these a lot, so I kind of have those memorized, but another way to think about our degree and radian measures.